make sure. I was typing so much. Okay, now it's working. Thank you for that. Oh my gosh. So thank you for letting me know about that. I didn't know that that wasn't working, so I appreciate that. So okay, so what we're gonna do here is we're gonna go ahead and build graph for the edges from the edge list. We're gonna build a graph and that's gonna return back to us an adjacency matrix. So we're gonna go ahead and do that first. So we're gonna say, hey, def build graph, and it's gonna take in our edges, which is an adjacency list. And then we're gonna say that what we want to return back is an adjacency matrix. So for, and what I'm doing here is I'm dissecting, or not dissecting. The word that I'm looking here is destructuring. So what I'm doing here is just destructuring here. Essentially, this is here is A, this is B as well. So what I'm just doing here is just destructuring. So for A and B and edges, I'm saying that for, hey, for this A and for this B part in edges, we're gonna say that, hey, let me make sure my indentation is good. So we're gonna say that A is not in graph. If it doesn't exist yet, we're gonna set you to, we're gonna go ahead and set you to an empty list. Essentially, I'm gonna say, hey W, I have never seen, so we're gonna go ahead and traverse through our list. You know what? That's a good question. You don't always have to, but as of right now, when I'm going through it, I have found it easier to go ahead and traverse through a matrix versus doing a list. But if you have figured out a way to just do it with a list instead of a matrix, feel free to let me know what your thoughts are. I love to compare our code. So yeah, I found it easier to traverse through an adjacency matrix instead. So feel free to let me know what your thoughts are too as well. So essentially this is saying, hey, I found W, but now because since W is not in our graph, we're gonna go ahead and set it and initialize it. So we're gonna go ahead and initialize it with an empty list at the moment. Same thing goes for B. If I have not seen you in our graph, we're gonna go ahead and set you up to an empty list too. And now comes the fun part. Okay, now we're just gonna add. So now we're gonna say, hey, if graph of A, we're gonna go ahead and add our B. So it's saying that, hey, we see our B right here of X. We're gonna go ahead and add B into our list right here. So that is what it's doing into, because W will always stay the key, and then the value is where we're starting to add in the other edge. So graph of B dot append A, and then we're gonna do the same thing. So this is going to go ahead and return us a graph, and I wonder, I should be able to print out the graph. See, as you can see right here, I wonder if there's a way to make it prettier, because I wonder if you can see it. Nope. Okay, well, this isn't too bad, but essentially, as you can see right here, W is saying, hey, W is saying here that I point to X, and I also point to V. X is saying that I point to W, and I also point to Y. So that is essentially what we're doing right now. Oh, but okay, we can go ahead and delete that. So after we're doing that, as I mentioned before, we're gonna go ahead and do shortest path. You want to think about breadth first search right away. That should be like your technique to go to. So I am, for Python, from the collections library, I have to import deq. Is it deq? DQ. I think it's called DQ. I want to make sure I say it right. So with Python, it doesn't naturally have a queue in it, a natural data structure of queue. So we're gonna go ahead and use the double-ended queue, hence why it's called DQ. And so we're gonna make it act like a queue. So we're gonna say the queue is set to a DQ, and we're gonna go ahead and add in our first node, which is A, because we know that our starting point is always going to be starting at A. So we can go ahead and add in the first node because we know we're going to go ahead and start there. So yeah, so our queue is going to go ahead and have the starting node, and we're going to say that we're going to keep traversing queue as long as it's not empty. So we're going to say, hey, current is equal to queue.pop left off. And if you remember the structure of queue is FIFO, first in, first out. Hence why we're going to come from the left, and that's why we're going to pop left. And when you say queue.pop left, it's going to go ahead and give you that node value that's in the first line in the queue. And we're going to look at that current. And what we're going to actually state here, I forgot, that's right. We did say that we're going to add a distance to it as well. And we're going to say that it's going to start at 0. Let me think. Because DQ, it's like this. But I want it to be a tuple. Okay, thank you. Thank you for confirming. I've heard it both ways, so that's why I got myself confused. And, okay, so I am saying here that, hey, add the node value into the queue along with its current distance. And we're initializing this to 0 right now because we're starting from point, like the first point of A. So we know in my example up here, we're from W to Y. We know that W is in our queue right now. And we know that its distance right now is 0 because we haven't moved yet. So we're going to say that, hey, if the current node is equal to our node B, which is our target, what we're looking for, we can just go ahead and return that distance. Otherwise, what we need to do is for neighbor in graph of current, we're going to go ahead and traverse through this side, we're going to go ahead and traverse through the value, which we are going to call it its neighbor. And we're going to go ahead and look that up here in the graph. And we're going to look up an X. And we're going to say, hey, we need to add you to check you next and your neighbors next. So we're going to go... I want to make sure my indentation is good because it will yell at me. And so we're going to go ahead and add the neighbor. But if you think about it, one thing that you always have to be worried about with graphs is just make sure to avoid any cycles. And the best way to go ahead and avoid any cycles is go ahead and make sure you add a set. This will go ahead and tell you like, hey, I've seen this node before, don't check it, you can go ahead and move on. We know that there's no path here remaining to that specific node. So with this set, we can go ahead and add in our node A. We can go ahead and add in our node A. And I am going to add it as a tuple. I'm just trying to think. I'm going to go add it as a tuple. And then one thing for sure, if for the neighbor in the graph current, we're going to say that, hey, if the neighbor not in visited. So, hey, saying, hey, if I haven't seen you yet, we're going to go ahead and add the neighbor. Then we're going to go ahead and I feel comfortable enough to go ahead and add its neighbor. So we're going to go ahead and add it all in together. Otherwise, we know that at the end, after checking all of our neighbors, and wait a second, we added our neighbor. Okay, so yet I want to pay attention to, okay, so visited dot add neighbor. In this one, oh yes, okay, so we have to pay attention to how we set it up here in our queue. Oh my gosh, thank you for subscribing. I appreciate you being here. So we have to pay attention to how we set up our data structures here. As you can see, in our queue, we have the node value itself in the distance. And that's my fault because we did the Q and we're adding the neighbor's value, but we never updated the distance. So we're gonna have to go ahead and update the distance plus 1. So as you can see here too, I have another parenthesis, so it's a tuple. And I just want to make sure all of this is correct. And then otherwise, okay, so let's do a quick run through. So we know for sure, and we saw it earlier, that we had our graph right here. So I feel comfortable with how our graph, I'm just gonna add right here. So this is how our graph currently looks like, and we built it correctly. So this is saying that, hey, RW, it points to these 2 specific edges. No, of course not at all. You're not at all bothering. Some of the stuff you gotta do as a streamer, right? So, yeah. So, okay. So as you can see right here, we're saying, hey, this is gonna this node right here. It points to these 2 specific other nodes, but we need to go in order to go from here to here. It's a 1. You have to move through an edge. An edge is essentially W. So a W, and then you have your, you can do a W and X. So from this is a node, we call them, you can call them vertices as well. Essentially they are just node and they hold the values, but an edge is the line that connects them together. So the edge is the line that connects them together, and we know that from get to W to X we have to cross 1 edge. So that is plus 1 right there. So we know we're going over 1. And so we know that's how our graph is right now. So currently, let's go ahead and walk through this example here. So currently, if we walk through my example, because I have a W and a Y and a 2, this is what I anticipated to see for the example output. So right now, we're going to go ahead and know that we're for sure starting at W. So we're starting at W, and our W is saying, this one is saying, our Q right now is saying, hey, we're at W and 0. So we're saying in this tuple, we have this node value of W, and we also have a distance of 0. And now we're also saying, hey, this is what we've seen so far. This is, sorry, I should put it in this correct string. So this is what it's saying so far. This is saying that, hey, W, you're the only string that we have seen so far. So we're gonna work through our Q, and we have, our Q has a length of 1. So we're gonna go ahead and enter the while loop. And we're gonna say, hey, the current node, we're gonna call that what it is. I guess I can call it node too, but we're going to call it current. We're going to say, hey, current in the distance, we're going to go ahead and take you off of the queue. So then now our queue is going to be empty. So now our queue is going to be empty, and now we can go ahead and take a look at you. And we're going to go ahead and check, hey, put it in comment. Hey, is W, are you what we're looking for? Are you Y? And it's, as you, in this example, we know that it's not Y, so we're not going to return any distance, so we're going to go ahead and just jump over to the next line. And the next line is saying that, hey, for its neighbor in the graph of current, if we haven't seen it in visited, which we haven't seen in X yet, we're going to go ahead and say that, hey, visited, you're going to be updated to with Y, and now we're going to say that, hey, next on our Q that we're going to add in is, or sorry, not Y, our X. So it's going to say, hey, X, we're going to be added to that, and we're going to go ahead and increment our counter for distance, because we know we travel at least once. So that's what's currently happening, and then, so that's what's currently happening, and then we are going to go ahead and go through, because our queue is not empty, so it's going to say, as you can see right here, we're going to go ahead and pop off our tuple of or sorry, string of x in distance of 1. And we're going to say, hey, does x equal what we're looking for? No, it doesn't. So now we have to go ahead and travel through x. We have to go ahead and travel through x values. We have to go check to see if it's in visited. Have we seen y or w? We haven't seen y or w yet, but now we're going to go ahead and update y and w. And now we're going to go ahead and add all of the neighbor onto the queue. So we're going to add y, and we're going to increment to 2. Oops. We're going to be like this now. And then also we have to go ahead and add w and the distance of 2 as well as to the queue. But what we're going to do is we're going to go ahead and pop left. And pop left will always give you the first value. So we're going to go ahead and check this one first. So this one will be popped off of the queue. So all that's remaining left on the queue is a W. And Y, as you can see, Y and 2. Now we're going to check, does the node equal what we're looking for? Does y equal y, what we're looking for? If so, then we're going to return the number that's affiliated with that. And that, I feel strongly with it, and that's where it's going to return the distance. We're going to exit then that's when we're going to go ahead and exit the loop because we found what we're looking for. And I feel comfortable. No! Okay, takes exactly 1 argument, but I gave it 2. Okay. Let's see. It's okay. That's my fault. Because I think it understood it as neighbor. Yes! We did it. Okay. That was my fault for not putting another parentheses around it. I hope that kind of makes sense for you guys. Please let me know what your thoughts are for me to explain that. I hope that kind of makes sense. Breath first search did take a while to digest in, but the concept, the boilerplate of it does make sense because you have to use in Python's world. In Python's world, you go ahead and use a DQ, and you're gonna go ahead and pop left, and you're gonna go ahead and check this current node and say, hey, current, are you what we're looking for? If not, then we're gonna go ahead and add your neighbors next to it. And then we're gonna keep going that way. Breadth first search is really good for shortest, anything closest. For trees, it's good for level by level. So, yeah. Any questions? I'll do my best to go ahead and answer it. Oops. Add it in Algo. But yeah, I've been loving this as well. And so we're going to go ahead and do some reviews of some free code camp. Let me grab my charger quick. So we're going to do a page. We're going to do other as well. Yeah, let me know. How do you... Please forgive me for... I hope I don't butcher your name wrong. But Aaron saying, are you familiar with algorithms? Are you a big fan of them? So let's go ahead and review some free code camps. So truly and falsy values and how do Boolean operators in short-circuiting work. So in the previous lesson, you learned how to use comparison operators and conditional statements to control the flow of your programs. So while these are powerful, you will also run into situations where you need to compare multiple values at once. This can lead to nested conditional statements. Oh my goodness, what programming language are you using? I'm always curious on what people's programming language of their choice is to do algorithms. So as you can see, if this is based on true, if this is true, and if their age is greater than 20, it is equal to 25. So if the age is greater than or equal to 18, print you're eligible to vote. Else, print you're not eligible. So if this is true, enter this second if statement. Otherwise, go ahead. If this is false, then we're gonna head and enter the else. As you can see, Python's very particular about indentation. So The above first will check if the is citizen is true. If so, then it will go to the nested if loop. Yes, I read that right. And since age is greater than or equal to 18, this will be printed. Python and Golang. Oh my goodness, I've been really wanting to get into Golang. How do you like Golang? And may I ask, like, what do you use it for? For backend, right? More, I assume. But I heard good stuff about Go, so yeah. But let's take a look at what truthy and falsy values are. In Python, every value has an inherent Boolean value or a built-in value. Many values are considered truthy, that is, they are equivaluated to true in a logical context. Others are falsy, meaning they evaluate to false. So here are falsy values. Non-false, the integer 0, 0.0, and any empty strings are all falsy values. Other values like non-zeros and non-empty strings are truthy. So all of these are false. And then I wonder, because I can spit it up here. So in this terminal, you can go ahead and write Python, and you will go ahead and maybe I'll clear it up first. Let me use another terminal so it's prettier. Python. Okay, so if I say print, okay, so you have to do the print boolean of 3. What do you guys think it will be? Truthy or falsy? Let me know what your thoughts are. Sorry, be right back. I'm back. Sorry about that. Okay, but let me go ahead and make this a little bit bigger. We just need to take all of it. Okay, so if I say, based on what we've learned, if I say print the boolean of 3, do you guys think this is a truthy or a falsy value? I definitely think it's going to be a truthy value, no spoilers, because based off what we read thus far, anything that is non-zero is going to be a truthy value. Yes. Okay, but if I go ahead and say print boolean of an empty string, what do you guys think this will be? A truthy or a falsy value? Let me know what your thoughts are. Yeah, you are right. Alright, you are right. It is true. How about, what do you think the empty strings are? Is it a truthy value or a falsy value? Oh, you know, that's a good question. Let's go ahead and do that. But for an empty string, it's gonna be a falsy value. Let's go ahead and see. What do you think? What do you think negative numbers will be? I think negative numbers will go ahead and still be truthy. Because despite it being negative, it will still, because since it's non-zero, it will be a false or true the value. What are your thoughts? Placing your bets right now. We're about to place the bets. I am saying it's truly let. It is truly, and then also you can say the print boolean of even a float. We'll do a float of like pi number 3.14. That's all I know. A pi number 3.14. Yes, we can definitely do that. But the boolean value of a 3.14, despite it still being a float number, I'm gonna say it's a truly value. And based off what we just read, 0.0 should be a falsy value, because since it is a zero value, it will be a falsy. I think everything except for decimal zero should be true. Decimal zero as in 0.0, or were you talking 0.0? Print boolean of 0.0. If it's 0.0, since it's still a zero number, I think it's gonna be falsy. Yes. Cause yeah, based off what this, cause I love this free code camp. Talking about like Python numbers. As you can see here, they gave a few examples of some falsy values in anything integer zero, float of 0.0. They were all falsy values. Fun stuff to learn today. So yeah. So now that we understand truly and falsy value, we can take a look at Boolean operators, which are known as logical operators or Boolean operators. So conditional operator is your less than or equal to, but Boolean operators are your and or not. So let's take a look at the first AND operator. So the AND operator takes two operands and returns the first operand, and if it's falsy, so AND is very strong in particular of looking at the left operand and making sure that it's true the first. If it's falsy, it just returns this. So both operands must be true for both of it to go ahead and to result to a true the value. So we're going to say that if this is true, which is a true the value, and age, it's going to go ahead and default to the second part. I think like in React, this is also called conditional rendering as well, because they do that as well, because you will have, say, if this, do this. I've seen this before in conditional rendering in React. Let me know if you guys have seen familiar concepts like that before too as well. In the above example, the number 25 is printed to the terminal because the AND operator will evaluate the second operand if the first operand is true, and the AND operator is known as a short circuit operator. Short circuiting means Python checks values from left to right and stops as soon as it determines the final result. That does make sense, because that's how I read it too for AND. If I see that this one is false, I just stop. I don't look any further at the second condition. So you'll often use AND within if statements to check if multiple conditions are met. Here's how you can refactor the earlier example to use the AND operator instead of using nested if loops. So you can say that if this is true and this is true, then print this instead. So now let's take a look at the OR operator. So the operator returns the first operand if it is truly. Otherwise, it returns the second operand. An OR expression results in a truly value if at least one of them is true. So the difference between AND and OR expression right now is for all of it to be true, the first operand and the second operand both need to be true. Otherwise, OR only needs one of them to be true. You can say one in OR aligns with because of the O's. So I like to think of like patterns of how I'm able to go ahead and remember all of this as well. So Yeah, it's also known as a short circuit operator. Here's an example. So age is equal to 19, is employee is equal to full. Your print age or is employee. So since the following code is truly, since 19 is a non-zero number, it's truly, it will go ahead and print 19 first. If you need to check one or more expressions is true, then you can use the or operator in a conditional like this. So if the age is less than 18 or is a student, you can go ahead and be eligible for a student discount. So this one is saying that if the age is less than 18, if 19 is less than 18, or so we already know that 19 is not less than 18, so we can go ahead and omit this. But we know that is student is truly, so we know that they get a student discount. So it's true. Since at least one condition is met, the entire or expression evaluates to true. So the discount message is and the if condition is printed. Sorry about that. So the last operator we will look at is the not operator, which takes a single operand and converts it into a Boolean value. It converts truly values to false and falsy values to true. So the way I think about a not operator is the opposite. I think of it as an opposite. So unlike the previous operators we looked at, not always returns true or false. So as we said before, not empty strings. Empty strings are truly. So this one will return false. So the opposite of what it is. Since this is yes, this is not empty, so this is truly. This is falsy, but then not converts it into true. So fun stuff. It is common to use the not operating conditionals to check if something is not true or false like this. So is admin is equal to false. If not is admin, so this will be true. So we're gonna go ahead and print access denied for administrators. So it's saying that not false, which is true, the access denied for non-administrators will be printed. Yeah, now that you understand in or not operators in short-circuiting work, you can write more flexible and readable conditional logic. So let's go ahead and do some of their fun questions. I love how FreeCodeCamp adds some questions at the end to test the knowledge that you read. One of the best ways to go ahead and work with like active recall is being able to remember exactly what you read and being able to go ahead and apply it as well. So, okay, let's go ahead and work on this code output. So we have an age that is equal to 20 and has a ticket that is equal to true. So we're going to check, hey, if from this if statement that if the age is greater than or equal to 18 and has ticket, print you can watch the movie, else print you can't watch the movie. Do you think it'll be you can watch the movie, syntax error, type error, or you can't watch the movie? Let me know what your thoughts are. Let me grab some tea quick. Okay. So if age, we know that if 20 is greater or equal than 18 and has ticket, so we know that 20 is greater than or equal to 18. So this part is true. And for the and operator, you need both to be true for the operand. So if age 20 is greater than or equal to 18 is true, which is true, and has ticket is true, which is truly. So all of it does the if statements to go ahead and default to a true, then we can go ahead and print you can watch the movie. Which of the following is not considered a falsy value in Python? Empty string 0.0, a string of false, or 0. Let me know A, B, C, or D. Let me know what your thoughts are. for this, as we discussed a little bit earlier before, is that anything what's considered an empty string is considered falsy, a 0.0 is considered falsy. A string of false is not considered falsy. It's truly because it is non-empty and non-zero, and we know 0 is false. So that is the case. So what happens when Python evaluates the expression x or y? What happens when Python evaluates the expression x or y? We need at least one of them to be true. It returns x only if both x and y are true. It doesn't return just only x. It returns x if it evaluates to true and skips evaluating y. It does. Because if we know that x is true, we don't have to worry about y. Because for or, we only need one of them to be true. So it always evaluates both x and y regardless of their values. It returns, I'm leaning towards B. Let me know if anybody else has any other opinions or thoughts as well. But this one should return B because it will return x if it evaluates to true and skips evaluating to y. I feel strongly. Yes. Okay, so I think what's next after this? I can't remember. So we did all of the theories, which is exciting. So we're going to build a Caesar cipher. Oh, this is fun. Okay, but this more to come. So I love the Python certification. As you can see, we still have a lot to go through. But I think this will be fun. Okay, so this will be fun. I'm excited for it. I'm excited to learn all of these more in depth. We will do one. I'm kind of curious. As you may recall from previous lessons in Python, you declare a variable by writing the variable name on the left side of the assignment operator. And you assign it to that. Yes. So variable name is equal to value. We're going to create a variable name. Oh, does it let me? Or do I write here? Oh, okay, cool. Okay, I write here. So we're going to say shift is equal to 5. Nice. Okay, this is fun. Okay, let's go ahead and do this. Okay, so I don't think it'll take me too long. In previous lessons, you learned about different data types you can store in a variable. So you just assigned an integer value. Now you need to assign a string, which is a sequence of characters enclosed by either single or double quotes. So we're going to declare a variable called alphabet. And we're alphabet. And assign a string to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. You should assign this string to your alphabet variable. You should assign, maybe I didn't spell alphabet right. Sorry, your code does not pass. Okay. Let me know, chat. Did I do that wrong? Okay, so we're going to assign this string to your alphabet variable. This is not alphabet variable. Alphabet. Misspelling there. A, B, C, D, E, F, G, H, G, I, G, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. I could definitely do... I want to take a screenshot. I was like, I think I did it right. So, okay. So we're going to build a Caesar cipher. I think I've seen this one before in algorithms. I don't think it'll be... This is one of the simplest techniques to encrypt text, which consists of substituting each letter of the plain text with a letter found at a fixed number of the position. Okay. And then, so for example, with the shift of 5, A would be replaced with F, B, and G. Okay, so 1, 0, 1, 2, 3, 4, 5. So 5, as you can see, F would be starting here. And since strings, you start at the 0 index, that's why I got to 5 here. So we're gonna create a variable named shifted alphabet. Shifted alphabet. Alphabet. And use the slicing syntax to assign it to the portion of the alphabet that starts at the index of shift. So I'm gonna say alphabet alpha bet. So slicing is such a beautiful thing. You can use it for strings. I use it a lot for string, where it's gonna go ahead and take a start, a stop, and if you wanna increment, start, stop, increment. I'm pretty sure the third one is increment, but start and stop for sure. So it's gonna go ahead and take in three items. So we're gonna start at, so it starts at the index of shift. So if it's gonna start at the index of shift, this will replace our start. Then call it the printin function to print shifted alphabet. And now you need to go ahead and print it. And as you can see, FGHIGK, etc., etc. I'm so sorry. So, yes. Okay, wait. You should assign alphabet shift to shifted SHIFTED underscore ALPHABET. You should call print function passing in. Oh, sorry. Hold on a second. about that. Let's do this. I'm like on a roll. Okay, so okay. So as you can see from the output, the shifted alphabet starts at the letter F because shift has it at the value of 5. But now the first 5 letters of the alphabet A, B, C, D, E are missing from the shifted alphabet. So you'll need to add them at the end of the shifted alphabet. The plus operator is used to combine 2 or more strings together in a process called concatenation. So you're going to go ahead and use the slicing index to extract the first portion of the alphabet and concat it with shift. As a reminder, sentence is start, stop. Returns these characters of sentence from position start included to the stop. From position start included to the stop. Okay. So you'll need to add them at the end. Okay, so the way I would go ahead and add it to the end is I would say, hey, alphabet. We're gonna go ahead and say, you're gonna start, so this starts at the 5. This one is gonna be ending at the 5. And this is what I'm gonna say. Yes. Let's do one more. Now that you have your entire, remove the printed alphabet call. So the string.makeTrans method takes 2 strings of equal lengths and returns a translation table. These must be the ASCII characters. You'll learn more about the type of structure returned by later on in the curriculum. For now, create a translation table that maps the all characters in alphabet to the characters in the shifted and assign it to a variable named translation table. So you're saying, okay, so for now, create translation table that maps characters in alphabet to the character. So now we're going to say a table is equal to string of alphabet. String.makeTrans of alphabet. This will create the table. And now create translation table. I created the table that maps the characters in the alphabet to the characters in shifted alphabet. So now, actually, this one, would we say translation table? If you're saying I need to say to string.makeTrans of because to the characters in shifted alphabet and you should declare a variable named translation table. You should call passing in alphabet and oh, I see. Okay, alphabet and shifted alphabet. The reason why I'm doing it under, as the code reads from top to bottom, this will go ahead and get alphabet and shifted alphabet and assign the result. We're gonna assign the result to that. Okay, cool. Alright, but it's almost time for dinner, so I'm gonna go ahead and get some dinner. So thank you for hanging out with me. I appreciate you guys all coming out today. I really do. So more to come next week. Let's go ahead and hang out soon. So let's go and raid people. Oops, raid browser. Appreciate you guys all coming out. This has been fun. Let's do it more though. Yeah. Vision. Pattern. Oh.